My channel NJ Math World. Today I am going to discuss about computational discrete mathematical mathematics BCA first semester SEP syllabus. We are going to discuss about SEP syllabus first semester BCA computational discrete mathematics. The subject code is CA01T3 and the marks for the final is 80 marks. They will be getting 80 mark question paper. So we'll be discussing the paper here today, first unit of the paper. So here we have unit 1, it is a foundation. In foundation we'll be discussing about a fundamental of logic, then preposition logic, then logical connectives. In logical connectives we have negation, disjunction, biconditional, conjunction, conjunctional implication, and converse, inverse, contrapositive, tautology, contradictions. These are the topics which will come in the connectives and truth tables. Then we'll be learning about the applications of prepositional logic, then logical equivalence, then identities of law, predicates and quantifiers, nested quantifier, rule of inference, the introduction to proof, method of proving theorems, proof methods and strategies. So these are the chapters which we are units which we are going to cover in this part of video. So here first we have what is logic. What is the fundamental of logic? What is mean by logic? Logic is nothing but it is a science of reasoning. Logic is nothing but it is a science of reasoning. When we give reason by using some scientific examples, so we talk about the logic. So here in logic in mathematics, the rule of logic gives the precise meaning to the mathematical statements. So whatever statement we discuss, we'll be discussing about using the logical rules. So here we have prepositional logic, which is an important question. Yeah, we will be getting. Usually, you get this question in the paper. So, what is a prepositional logic? Prepositional logic is a statement, is a declared statement which is either true or false, but not both. So, it says that the statement which is always true or it is always false, but it should not be both. It is called as prepositional logic. So, for example, if you take Mumbai is a capital of India, Bangalore is in Karnataka. 1 plus 1 is 2 and 2 plus 2 is 3. So here preposition 2 and 3 are true, right? Mumbai is a capital of India is false. Bangalore is in Karnataka, it is true. 1 plus 1 is 2 is true and 2 plus 2 is equals to 3 is a false statement. So yeah, 2 and 3 are the statement which are true. Now, some statements that are prepositions are shown below. Do you do your homework? So, here, do your homework. Where are you going? X plus 1 is 2. May God bless you. So, here, statement 1 is command, hence not preposition. So, commands cannot be prepositions. Okay. Then, sentence 2 is a question. So, that is not a statement. Again, if it is in the form of question, it is not a statement. Then yeah, you have statement 3 is declarative sentence but not a statement, and since it is true or false depending on the value of x. So here it is a statement is a declarative sentence but it is not a statement. Then sentence 4 is a exclamatory sentence, and so it is not a statement. So yeah, what is a statement? Whenever you get a impre imperative, exclamatory, and interrogative or open statements are not statements in logic. Mathematical identities are considered to be a statements. So logical identities means a square plus b square is equals to 2a square plus b square plus 2ab is equals to a plus b whole square is a statement in a mathematics. So yeah, we usually represent the truth table by using 1 and t. 1 means true and 0 means f false. So yeah, 3 is a prime number. The statement is true. So we write the true value of p is 1. Every square is a rectangle. The statement is false. It cannot be every square cannot be rectangle. So the statement is false. The true value of q is 0. So for true we write it as 1, and for false we write it as 0. So here logical connectives. These are very important logical connectives. We use the connective words to connect two statements. Okay, so that is and, we have and, then not, and if, then if and only if. So these are the four connectives which we'll be learning in our topic. So yeah, first one is called negation. What is negation? A preposition obtained. Negation is a preposition obtained by inserting the word not at a appropriate place in a given preposition is called as negation, and it is represented as the symbol. Okay, any one symbol can be used to represent the negation. What is negation? Now for example, P, New Delhi is a city. So what will be negation? New Delhi is not a city. Then other one, 6 is a multiple of 6. So negation of S will be 6 is not a multiple of 6. So this is negation. For now, let's conjunction. What is conjunction? If two statements are combined by the word and to form a compound preposition, statement is called as conjunction. So when we are using and to connect the two statement, it is called as conjunction. And what will be the symbol for conjunction? We represent it as and, that is cap. This cap is represented for conjunction, and means nothing but cap. Okay, so yeah, for example, P and Q are two prepositions. So yeah, P 2 plus 4 is 6 and Q 6 is a factor of 12. So when you combine the P and Q, it becomes 2 plus 4 is 6 and 6 is a factor of 12. So we are going to combine and two statement by using and, that is called as conjunction. So now for example, rose is red. If I take P as rose is red and Q as rose is pink. Rose is pink. So what will be this conjunction? P and Q. P and Q will be rose is red. Rose is red. We are going to use and rose is pink. It's called as, this is a statement where we use the conjunction and. Okay, so what will be the truth table for this conjunction? Truth table is very simple. What you are going to do, how to remember that? P, P, Q, P and Q. Okay, certainly T, T, F, F. Always truth table will be written like this. Then T, F, T, F. T is true and F is false. So for, so yeah, if you take for and, what is it? We have to take T and T, it is T. Otherwise, it is false. Otherwise, it is T and T, it is T. In other all cases, the answer will be false for conjunction. Okay. So, whenever it is true and true, the answer will be true. Otherwise, the answers are false for the conjunction. Then, moving with the next one, we have next connective is disjunction. What is disjunction? If two statements are combined by the word or to form a compound preposition is called as disjunction. So when we are adding two statements by using the word or, connecting two statements by using the word or, it is called as disjunction. So yeah, P is given as 2 plus 4 is 6 and Q is given as it is raining outside. So I want to join this both the statement by using or. So here P or Q will be 2 plus 4 is 6 or it is raining outside. So we are using and or here to connect the both statements. So it is called as disjunction. For example, if you take P, student is good. student is good. Q if you take student is bad. Student is bad. So now I want to join this by using a or. So P or Q, student is good or bad. Either the student can be good or the student can be bad. It cannot be both at a time. So what will be the truth table for this or statement? How we remember? So we have here P Q, P or P or Q. So yeah, again T T F F, T F T F. So yeah, whenever it is F and F for or, it is F. Whenever it is F and F, it is F. Otherwise, the answer is true. So for disjunction, if it is false and false, it is false. Otherwise, it is true. Moving with the next one, we have next connective is conditional or implication. So what is mean by conditional? Conditional. It is if two statements are combined by using the connective, logical connective, if then. The resulting statement is called as conditional statement. Conditional statement. So what is it? It is represented as arrow mark. So arrow mark represent it is implication. Okay. P implies Q means it is implication. Okay. So yeah, what is it? For example, if two P, if I will go to Australia, Q, I will earn more money. So I want to write it in the form of implication. If I go to Australia, then I will earn more money. Okay. So here we can take this as an example for the question, and we will solve this. So yeah, we have I have an headache. I will take aspirin. So how do we write if in the condition if you want to write that if I have an headache, if I have an headache, then I will take aspirin. The other one, I take a walk, I will reach late. If I have to walk, I will reach late. So we are using if and then in the statement. He is a lawyer, he is graduate. If he is a lawyer, then he is graduate. So these are the example for if then. Then here you have what will be the table for this if then. How do we get the truth table? The truth table for if then will be if it is P and Q, P implies Q. P, that is T, T, F, F, T, F, T, F. What is the condition for this? So here it is T and F, the answer will be F. T and F, the answer will be F. Otherwise, it is all true. Only in the condition T and F, it is F. Otherwise, the condition will be true for implication. So, moving on with the next one. Next is biconditional or double implication. What is biconditional? If P and Q are any prepositions, then P if and only if Q is called biconditional. So if you use the statement word if and only if in the sentence, then it is called biconditional or double implication. So what we are going to use? We are going to use if and only if for biconditional. Okay. So yeah, what will how it will be represented? It will be represented into double arrow mark. It's represented as double arrow mark. For example, bird flies, sky is green. So here we are going to write it in double implication. Bird flies if and only if sky is clean. The other one you can take flight, you buy a ticket. You can take a, so answerly, you can take a flight if and only if you buy a ticket. Okay. So yeah, what will be the table for this by conditional or double implication? It is, yeah, P Q P double implication Q. So P T and T, F and F, T T F F. So what will be for double implication? It is when it is T and T, the answer is true. When it is false and false, it is also true. The otherwise, the answer will be false for double implication. Okay. So these are the four connectors which we'll be learning. First one is a negation. Negation represented as arrow mark and it is not. Second one is conjunction. Conjunction is represented as and symbol is cap. Then a disjunction. Disjunction was or and it is reverse V. Then implication. Implication if then and it is represented as single arrow. Then double implication. Double implication. Implication if and only if and only if with the double arrow mark. So these are the important connectors which we have learned till now. So we'll be moving on with the next topic for the. So we are going to this is again an important topic which will be getting a question on this. It is converse, inverse, and contrapositive. You'll be having it every paper. You'll have one type of question in this. So what is converse, inverse, and contrapositive? We will be discussing about this topic. So yeah, converse is nothing but if they have given any statement P implies Q, then converse. Converse is nothing but writing the statement in the form of Q implies P. Example P, it is raining. Q, student is absent. Then Q implies P if student is absent, is absent, then then it is raining. Will be the answer. It is called converse of the given statement. Okay. Then you have next one is inverse. What is mean by inverse? Inverse will be negation P implies negation Q. So yeah, we should negate the statement. Certainly, negation P. Negation P. If it is if it is not raining, if it is not, negation is using not in the statement. Negation Q, student is present. Opposite of present is absent is present. So either you can write not absent. In place of not absent, I'm using at present. Present. Okay. So yeah, what will be the answer for this? If negation P implies negation Q, if it is not raining, if it is not raining, then student is present. It's called as inverse of the given statement. Then next one you have is contrapositive. What is mean by contrapositive? Contrapositive is nothing but next one is contrapositive. Contrapositive. What is contrapositive? Contrapositive is negation Q implies negation P. It is nothing but inverse of inverse of inverse statements or opposite of inverse statement. So yeah, we have to write first Q and then P. So Italy negation Q implies negation P will be if student is present. If student is present, then then it is not raining. If student is present, then it is not raining. It's called as contrapositive. This is a very important topic where you will be getting many questions from this part. Like you'll be getting the question from this part: converse, inverse, and contrapositive. So what is mean by converse? What is converse? What is inverse? And what is contrapositive? So yeah, we'll just recap it. So yeah, we have first one is converse. What was converse? Converse is nothing but you write the statement in form of Q implies P. Then what is inverse? Inverse is negation P implies negation Q. Then what is the contrapositive? Contrapositive. Contrapositive will be negation Q implies negation P. So this is very important topic which you need to remember. So moving on with the next one, we have, so there are many examples which is given in the textbook. You can just refer the textbook for further questions. Okay. So now we'll move on with the statement: construct a truth table for the following compound preposition. So how we will be constructing a truth table for the given preposition. Okay. So yeah, we have given, there are three unknowns, that is variables, that is P, Q and R. Then you have, it's given here P or Q. So totally next one will be P or Q. Then again along with P or Q you have and R. So you'll write next one P or Q and R. So this will be your first part. Then second part they've given us, it is Q and R. First you will be taking the bracket what you have, that is Q and R. Then you will be having P, R, Q and R. So it will be P and Q or Q and R. This is R. Okay. So once again, I'll write it again. It is P or Q and R. So how we are going to construct the table for this? Look at carefully. So this construction of table will be there, for truth table will be there. So you need to understand how to solve this. Look on the and try to understand. Okay. So first you will need to write the one which is there in the bracket, and then you will be writing the outside part. Okay. Might be my lines are not proper as I'm doing it in the on board. Little you need to adjust. Okay. So here we have, if it is 3, we will be writing it as 2 to the power of 3 terms. That is 3. Certainly 2 into 2 into 2. So we will be getting 8 outputs. Okay. So we have 3 unknowns. So 2 to the power of 3 will be 8. So we will get 8 unknowns. So how do we write 8 unknowns? It will be T, 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 T. Certainly T and then again T. 4 times T and 4 times F. Then when you take second one, it will be 2 times T. Half of that, 2 times T, 2 times F. 2 times T, 2 times F. Then the last one will be 1 time T, 1 time F. 1 T, 1 F. 1 T, 1 F. So now we'll solve this. Carefully look here how to solve. So here we have first one P or Q. What is mean by or? Or was what? Or means what? Or is F and F, it is F. So yeah, we'll just check where we have for P and Q, means first and second line. We'll check where is F and F. So we have here F and F, F and F. So we'll write it is F and F. Okay. Then the remaining all will be T. Only the two place we have. So the remaining all will be T. Then we'll go for the next one. Next one we have, it is P or Q. That is this line, fourth line. We write 1, 2 and 3, fourth line. and R. R means fourth and third line. We'll be checking in fourth and third line. Okay. What we have to check? We have to check for the condition and. What is mean by and? And is nothing but T and T. It should be T. So yeah, we'll just check for the condition T and T. So we have yes T and T. It is T. Then yeah, we have here T and T. It is T. Then anywhere else we have here T and T. It is T. Then nothing. So the remaining will be false. So remaining all will be false. Then we'll move with the next one. Next one we have is so here we will be finding then Q and R. Q and R you have T and T it is T. We will be condition is T and T it is T. So the remaining all will be false. The remaining all values will be false. Wherever we have T and T it is T. So it is T F F F. Then we'll move on with the next one. We have P or Q and R. Then we'll be proving it for and. That will be proving it for first and the last one, that is first and sixth column. We'll be checking in first and sixth column. We'll be getting a condition is or. The condition or is for first and sixth one. The condition is or. So what we will be getting here, so what is the condition for or? It is F and F, it is F. So we'll prove for F and F it is F. We'll just check out. So do we have F and F? Yes, we have here F and F, it is F. Then next F and F we have F. Then F and F we have F. So the remaining all the values will be T. All the remaining values are T and T. So now we are just checking out. This is the way how you will be constructing the table compound proposition. So now moving with the next one, you have many examples given in your textbook. You can just go through with those examples and refer the questions for further. Now we'll move and we'll just solve one problem example, that is problem number 15. So if they are given P and Q be the two primitives or prepositions such that P implies Q is false. So here determining the truth value for the following. We have to prove it is by using the truth value. So here P implies Q is nothing but if P is T and Q is F, then the value is false according to implication. So now P value is true and Q value is false. We'll just check for the condition. P is true and Q is F, false. Okay. So the first one is P and Q. It is true and false. It is false. Then second one is negation P and Q. Negation P is, we will be taking here P implies Q is nothing but it is P is true and Q is false. We get the answer as false. So the condition P will be true and Q will be false. We'll check with the condition whether the given statement what the values will be there for the given. This is asking you to determine the truth value of the following. So here we have P and Q. P is true and Q is false. If it is true and false, the value will be false. Then it is negation P or Q. It is false and false. It is false. Then Q implies P will be false, implies true will be true. So that way we'll be checking the conditions for the given statement. So next one. Moving on with the next topic is your tautology and contradiction, which is very important question of your paper. In your every model question paper you will be getting in the, even in the finals you may get the question from here. It is tautology and contradiction, which is very important topic, which will be coming for 5 mark or 6 marks. So yeah, we will discuss what is it, what is mean by tautology and what is mean by contradiction. A compound proposition which is true for all positive values, true values of its component is called as tautology. So if you get all the answers as true, then the value is, then the table is said to be tautology, or the compound proposition is said to be tautology. So here we will just take an example which is given here. P implies Q and or negation P implies Q is a tautology. We'll just check for this given compound preposition whether the table is satisfies it is a tautology. So here P Q, and first we will be taking bracket P implies Q, then second bracket we have negation P, so it will be first negation P, and then it will be Q, that will be negation P implies Q. So we know that for two statement it is 4 values, that will be we have to prove 1 and 2. So I'll take this as 1, and then so 2 it will be 1 or 2 for the overall. Then by constructing the table we have the values are first you have to construct the table. So here the values will be T and T. What will be the first P? P will be, you have two statements, so it will be 2 square will be 4. So there are 4 answers what we will get, that is T and T, F and F, then T, F, T, F, then it will be implication P implies Q, condition will be if it is P implies Q will be T and F, it is F. So condition is T and F, F. So we will just check out where do we have T and F, we have F, the remaining all will be true. Then we have to take negation P, whatever values of P are there we will be negating that, it is F, then T and then T. Then negation P implies Q, negation P implies Q, that will be fourth column and second column. We will check the condition is for implication. So the condition is implication means what, again it is T and F, it is F. So we will be taking T and F, it is F. So yeah, we have the value T and F, it is F. Then again we have, no, we don't have anywhere, so it will be true. Then we will be checking for the first line and the that is P implies Q line and negation P implies Q line. The condition is, we will be checking for this and this column, the condition is OR. What will be condition? Condition is OR. OR means what? F and F, it is F. So we will be proving it for F and F, it is F. We don't have. Then second one also we don't have. Then we don't have for the third one, and we don't have even for fourth one. So if there is no F and F, then the remaining all will be true. Hence the values of the given components are true, then it is called as, it is a tautology. So when it is called tautology, if given all the problems values are true, then it is called as tautology. So moving on with the next one, we have is a contradiction. What is mean by contradiction? The second important question here is a contradiction. So what will mean by contradiction? So here contradiction is nothing but it will be reverse of the tautology. That contradiction means if all the values are false, then it is called contradiction. For all values are false, then it is called contradiction. If all values are true, it is called tautology. If all values are false, it is called as contradiction. So it is definition is a compound preposition which is false for all possible true values of its component is called as contradiction. So yeah, we'll take one example and we'll prove. We have they've given here one example. Prove that P and negation Q is contradiction. P and negation Q is a contradiction. So if you want to prove it is a contradiction, what we need to prove? We need to prove the given answer will be false. So let us take Q and negation Q is tautology. So yeah, Q, then negation Q, then Q and negation Q. So yeah, T, it will be F, T and F, F and T. Then and condition is T and T, it is T. We don't have here T and T, so the both answers will be false. Since the values given here is false, the given preposition is a contradiction. Okay, now if it is all values are true, it is tautology. If all values are false, it is contradiction. But if it is neither tautology nor contradiction, then what is it called? So if a compound preposition which is neither tautology nor contradiction is called as contingency. If you get answer both T and F together in a truth table, then it is called as contingency. What is contingency? Contingency is a statement or compound preposition in which the values will be both true and false. Then it is called as contingency. Contingency means it is both the values will be true, both T and F will be present, that is true and false will be there in the table together, then it is called as contingency. For example, we'll take the example of P implies Q, P implies Q implies P and Q, P and Q. So now if you take to prove that contingency, we will take P, Q, then P implies Q, then second bracket P and Q, then both together, so we will call this as 1 and 2, then I'll take 1 implies 2, 1 implies 2, then T, T, F, F. So we need to prove it is a contingency. We'll take T, T, F, F for the first one, that is T, T, F, F, then T, F, T, F, then implication is what? It is T and F, it is F, otherwise it is true. So we have here in the second line, we have T and F, it is F, otherwise it is true. Then you have next one, that is AND condition. T and T, it is T, so we'll just check for P and Q, that is first and second column. T and T, it is T, then remaining all are false. Then we have to check for the first and second line, these two lines we will be checking for implication, that is T and F, it is F. Just check out where we have T and F, we have T and F, it is F, again we have T and F, it is F, the remaining all will be true. So hence both the values T and F is present, it is called as contingency. So here moving on with the next, we have learned three important things, that is tautology, contradiction and contrapositive. So the problems are given here, you can just go through with the problems to solve them. Okay, and you try to solve this exercise problems. Any problems you are not getting or you want my help, you can say, write it in the comment box. But students, if you want to learn the topic, you need to solve the exercise by yourself. Okay. So yeah, moving with the next one is application of prepositional logics. So we have many application of preposition logic. Logic is used in many different ways in our daily life. Logic, without logic we cannot do any calculation. For example, we use calculators and we use other things, but here logics are used in designing computer machine, artificial intelligence, data structure for programming language, specification of software and hardware, designing computer circuit, verifying correction of program, and build expert system. Logic can also be used in analyzing and solving the many family or familiar puzzles. Okay. So here we have some applications they have given are discussed in your book. So it is also used in mathematics and computer science. Some of the applications are, the first application in your textbook is given as translating in English sentence. What is mean by this? Any sentence which is given in English form, will convert it into machine form. For example, you can access the internet from campus. You are computer science major. You are a freshman. So if they have given you can access the internet from the campus only if you are computer science major, for you or you are not a freshman. So here the statement which is given in the example can be written in the form of symbol. So that is A will be you can access the internet from the campus, implies if and then is used, so implies symbol. C is what? You can you are a computer science major, then or negation of F, you should write negation of F is you are not a fresherman. So you are not a fresherman. So this statement will be written in the form of symbols. A implies C or negation F. So this way of writing is called translating English system, English sentence. So we are using there or means we are using or symbol not means we are using negation. So here not is given in the system, it's called negation. So this way of writing is called as translating English sentence. Then we have next one is a system specification. What is system specification? So yeah, system specification is system and software engineers take requirement in a natural language and convert them into a specification language that can be used as a basic for system development. So here any machine language, whatever language is given in a natural language, will convert it into machine language. That is called as system specification. So here example they have given here is P. The automated reply cannot be sent when the file system is full. So P will be the automated reply can be sent, and Q will be the file system is full. So negation P will be if it is not the case that the automated reply can be sent. So we can write this as Q implies negation P. Then the next application is we have Boolean search. We have a Boolean search. What is mean by Boolean search? Searching the most often operation does over the internet is called Boolean search. We'll be searching many different searching objects, like a student doing assignment, searching in Google, then any notes you want, you will be checking in the Google. You want any information, library books or anything which you want within a no time we will be getting it from the system. And here Boolean search is nothing but by using the connective and or if, then if and only if, and other symbols not okay, we'll be using it in the website. We'll be using it to find the vast number of websites by using the words connectives. Okay, so here logic connectives are used extensively in searching a large collection of information such as index of web pages. This search employ techniques from the preposition logic, hence called as a Boolean search. So for example, if I write Bangalore not university, so I'll be getting lakhs of information. Then other example, if I take New and Delhi or Karnataka and university, so we'll be getting they'll give the Boolean search will give you web page will be giving you information about New Delhi and Delhi, then Karnataka and then university. So it will give you lakhs of papers, lakhs of pages which will be showing you the words which has been given in the Boolean search. The next one you have is logic puzzles. What is logic puzzles? You might have puzzles which can be solved using rules of logic, which is called as puzzles. For example, you have magic squares, magic cubes, which will be using to solve the problems, and magic squares, magic cubes, which are you have even in a Guinness World Record. You have this logical puzzle game which within seconds of time if you do, you will be getting a Guinness World Record. You have to break the record which already the students have been done. Okay, so yeah, we have here puzzles we can see in magazine, we can see in book, we can see in newspapers, we can see in websites. We have different types of logical puzzles, and then the computer and programming which are designed to use a logical reasoning are tested using the well-known logic puzzles. Even the computer programming also designing can be used by using the checked by using the logical puzzle. The next one is logical circuit. Prepositional logic can also be used to design computer hardware. You can see here computer hardware, we have many different types of computer hardware, like if you take television, we have a motherboard which you can see which will be designed in the form of logical circuits. We have then you have a television, you have in that also you have a motherboard. Every electronic systems will be used by this invert or gate, NOR gate. This gates will be used to design a logical circuit which will be used to run any electronical devices. For example, your mobile, television, remote control. Okay, everything which will be operated by remote will be having logical circuit in that. For example, you can take a motherboard in your any one of the electronic devices. You can see there will be a green motherboard and they will be connected with and all this NOR gate. Now you have an example exercise problems. Again, you do it as this homework and just check out. If you are not able to do any, you can just message me, or you can reply me, so that if possible I'll solve the problems and send it, in your next video, in my next video. Okay, so next one is logical equivalence. What is mean by logical equivalent? Whenever you're proving that LHS is equals to RHS in a logical condition, LHS is equal to RHS equal to LHS, or LHS is equal to RHS, it is called as logically equivalent. It is represented as this three lines, and it is even represented as double arrow mark. Okay, double three lines, and it is even represented as double arrow mark. So you have here logical identities of laws of logic. We have logical identities and laws. We have the many different laws they have given. So here we will just discuss about some of the law. First one is identity law. P and T is P, P or R F is P. Then you have domination law, that is P or T, it is T, P and F, it is F. Then you have law of double negation. Negation of negation, P will be P itself. Then you have idempotent law, that is P and P is P, and P or P is P. Then you have commutative laws. You have P and Q, Q and P, P or Q, Q and P. Then you have associative law, where it says P and Q and R is logical equivalent to P and Q and R. Then you have distributive property, where distributive means if suppose you have a chocolate and two friends, we can distribute the chocolate into two friends. So that is you can take as a P and negation Q or R. We can take chocolate is given to P and Q are your two friends. So P and Q or P and R will be the this is distributive property. Then you have De Morgan law. De Morgan law says that negation of P and Q is logically equivalent to negation of P and Q is logically equivalent to negation P and or negation Q. The other one is negation of P or Q will be given as negation P and negation Q. So if it will be reverse of each other, then you have absorption law. Absorption law, P or P and Q is P. Then you have P and P or Q is P. Then you have P or that is negation. It is P and negation P is T, and P and negation Q P is F. Then you have equivalent law. Equivalent law is very important. P double implication Q will give you P implies Q and Q implies P. Q implies P. So this is called as equivalent law. Then you have logical equivalent involving conditional statement. You have many different laws which will be solving by using different this can be proved by drawing a truth table for the given statements. We will take one example from here, and I'll solve for you, and I want you people to solve all this logical laws and even the equivalent statement which is given in the book. Okay, I want you to solve this all the equivalency and prove that the LHS is equals to RHS. Okay, so solve this all, it will be easy for you to score marks in your final exam. So yeah, let me take any one of this either logically P and Q and R is logically equivalent to P and of Q and R. So it is a associative property. Okay, now we have to prove P this LHS is equals to RHS. LHS is equals to RHS. So to prove LHS, we'll take P Q R, then first bracket P and Q, then we'll take overall P and Q and R, then we'll take the second side, we'll take the first bracket Q and R, then we'll take all together P and Q and R. So we need to prove LHS is equals to RHS. So yeah, we shall prove LHS is equals to RHS. So yeah, if you're having 3 unknowns, we'll be having how many values? We'll be having 8 values. So we'll just prove by drawing the truth table. So yeah, we should prove LHS is equals to RHS. Okay, so let me take the color. Now it is what? T 4 times T 4 times F. T F F F F. Then it is T F F F F F F. Then 1 time T 1 time F, 1 T 1 F, 1 T 1 F, 1 T 1 F, 1 T 1 F. Now we have a P and Q. P and Q. And means it is what? And means T and T, it is T. So we'll check T and T, it is T. Then we have anywhere else for P and Q? No, we don't have. So remaining all will be F. Then we'll go for the next one, P and Q and R. That means we'll be checking for P and Q, this line, and R, the next line. So we'll check for the condition and means what? T and T, it is T. So T and T, it is T. F, 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 F. Then we have a next one is Q and R. We'll take Q and R, Q and R. So these two lines, Q and R, and means T and T. So it is T and T, it is T. Then we have false, then again false, then it is false. Then T and T, you have T and T, it is T. Then it is again false, and again false. Now we'll check again. Next one is we'll be checking for P, that is first line, and P and Q, the last one. So I'll check for this two. Condition is again and, that is T and T T. So we have T here and we have T here. It will be T. The remaining we don't have anywhere T and T. The others all are false. So now you have to find compare the LHS is equals to RHS. So your LHS is this and your RHS is this. Are they both same? If they are same, they are logically equivalent. Therefore, P and Q and R is logically equivalent to logically equivalent to logically equivalent to P and Q and R. Okay. I'll prove you one more. We'll take any one more other one and we'll try to solve. They'll give you verify the prepositions. Negation P implies Q and negation P and Q are logically equivalent. Okay, so okay, I'll prove this. Verify that the component are logically equivalent. So here we will take this. They have given P and negation Q and R is logically equivalent to P or Q and negation R. So we need to prove this too. So let us prove. We have first P, then Q, then R, then we'll take the bracket, negation Q, then we'll take whole bracket, negation Q or R. Then we'll call this as 1, 2, 3, 4, 5. We'll take first one, the P, and fifth one. The same way we'll take the other one also. First we will take negation R, then we'll take Q and negation R. Then I'll call this as 6 and then this is 7. So it will be 7. Then I'll take first one with the seventh one. So it will be 1 or 7. Okay. So here we'll prove this. We'll solve this part. will prove that they are logically equivalent. We'll check for the logical equivalent condition for this statement. So yeah, so here we'll prove for, so yeah, we have T T T T F F F F. Then 2 times T T T F F T T F F. Then 1 time T 1 time F T F T F T F T F. Then negation Q will be F F T T, reverse of Q, F F T T T, and then again T. Then we'll be taking negation Q or R, so that will be negation Q and R. Third and fourth we'll take. Third and fourth condition is or means T and T T. Sorry, F and F, F and F. It is F. Then we have here F and F. It is F. Otherwise it is F and F. 1 second. I have just written it here. Mm, 1 minute. Okay. So here it is T F. So here it is T. It is an F F T T F F T T. So now we'll take for negation Q and R. We'll check for these two conditions. We have, what is R? R means F and F, F and F. It is F. Then F and F, it is F. The remaining all is true. Then we'll go for the next one. We'll check for 1 and 5. 1 and 5 condition is and with T and T T. First one we have T and T, it is T. Then third one it is T and T, it is T. Then fourth one is also T and T, it is T. Fifth, sixth, 7, 8 we don't have. Then it is remaining as F. So this is your first LHS value. We'll prove for RHS. Negation R is F T F T F T F T, reverse of R. Then Q and negation R. So now we'll check for Q and negation R. That is, Q is second line and negation R sixth line. So we'll check for the condition. We'll be just checking condition is and. Okay, and that is T and T, it is T. We'll just check for T and T. So we have second one T and T, it is T. Then we have next one is we have here that is last third one, it is T and T, it is T. Otherwise it is false. So remaining all will be false. So yeah, it is false. Now we'll check for last condition, that is first and seventh one. We'll take first one and seventh one line and we'll check for or, that is F and F, it is F. So we have condition for F and F, that is first and last, F and F. No, this is also no, this F and F, it is F. Na? F and F, it is F. We have F, T, F, no. T, T, no. T, F, no. T, F, no. F, F, F. Then F, T, no. F and F, F. F and F, it is F. The remaining will be true. The remaining all are true. Now you can check the values of LHS and RHS. Okay, LHS and RHS. LHS is this and RHS is this. We'll just check the condition now. Check are they same? They are not same. LHS is not equal to RHS. LHS is not equal to not equal to RHS. Therefore, they are not logically equivalent. P implies Q, negation Q or R is not logically equivalent to P or Q and negation R. It's not necessary that all the values what they have given is logically equivalent. Some answer can also be not equivalent to, but you have to do it properly. Okay. Then we have here, we can even prove by using the laws in the property to prove the problem. So what we have, they've given like here next one they have given without using the table. If you want to prove it, show that the are logically equivalent by using the series of logical equivalency. Yeah, we are not using the table. Okay, so we will just check out how to do if they have given in this way, how we are going to solve that. So here they have given negation of P or negation P and Q. Okay, so they are logically equivalent to. So here it is what negation of, means we will be using this negation, we will be shifting inside. Okay, certainly negation P and negation of negation P and Q. Which law we are using? We are using the De Morgan law. De Morgan law. Okay, De Morgan's law. Then next one we have, it is logically equivalent to negation P, and again if you take this inside, again it is negation of negation P and will change it to or. So this is or, so it is changing here and. Okay, here and will change to or negation Q. Again we are using the same De Morgan law. Okay, second time. Then we have negation P, and negation of negation P is what? It is P. From where do we get that? We get that from double negation law. Double negation law. Okay, that double negation law say negation of negation P is P itself. Then we can write this as separate them and write by using De Morgan law. We are distributing chocolate to two of them, so totally negation P and P, or we'll take negation P and negation Q. So we have one more law where we say negation P and negation P and P is false. No, it cannot happen. So yeah, it is false. Then or this negation P and negation Q as it is. From where it is a complement law. Okay, negation P and P is false is a complement law. Complement law. Complement law. Huh? Then next one you have falls into something like we can interchange and write this. So F or negation P and negation P will be commutative property. By using this we can write negation P and negation Q, or F. We are using commutative property. Commutative property. Okay, or law. Then we have the last one, negation P and negation Q or F, means by using the identity law we can write this as negation P and negation Q, which is your RHS. So you started with LHS, you proved RHS, hence it is proved without using the truth table. Okay, even there you can prove it in this manner also. So now we will take the next part of this one, that is, so these are the truth tables and the values which you will be finding. Then we have next important topic is predicates and quantifier. What is mean by predicate? Predicates are the statements containing one or two variable. Okay, if it is having in a statement one or two variable, then it is called as predicate. Now one or two variable means, what is variable? Variable is nothing but alphabets. If you have one or two alphabets in the statement, then it is called as predicate. Okay, for example you have x is greater than 3. X is a variable, one variable which is greater than 3 is a predicate, example of predicate. Then other one you can take x is equals to y plus 5 is another predicate with two variable. When it is having one variable, when it has one variable, it is called as unary predicate. Unary unary predicate. When it has two variable, it is called binary predicate. And if it is having more than two, it is called nary n-nary predicate. Okay. Then how the problems will be there for this? They'll give you one statement. You have to prove by substituting some values for the problem. Now they've given here with two variable. If I take this example, x comma y denoted by the statement x uh, is equals to y square plus 2. So yeah, if you take x and y and x value is 1 and y value is 2, we get 1 is equals to 2, 4 plus 2, that will be 1 is equals to 6, which is not equal, it is false. Then you take 2 comma 0, x is 2 and y is 0, 0 plus 2, that will be 2 is equals to 2, it is true. Then you take second next one, 6 comma 2, x is 6 and y is 4, x is 6 and y is 2, 6 plus 6, 6 is equals to 4 plus 6, 4 plus 2 is 6, it is equal, it is true. So this predicate is solved by using substituting that suitable values for the given problem. Then you have next one is quantifiers. What is mean by quantifiers? Quantifiers. So quantifiers are of two types. That is, we have for all is one quantifier which is called universal quantifier. Universal quantification. 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 Okay. When we use for all, it is called universal quantification, denoted as for x p of x. Then you have other one is called first one it is, then second one you have it is existential quantification. It is existential quantification. So in this we'll be using there exist, which is denoted as e. So here it can be written as for all e p of x denoted. Okay, so there are two types of quantification. First one is for all, which is called universal quantification. We write it as for x p of x. Then we have existential quantification. There the word uses there exists, denoted as the symbol e. There exists x p of x will be denoted as this way. Okay, so yeah, for example you can take any one of this example. I'll take the p of x is x plus 5 is less than 6, is less than 9. Then for all x is greater than or equal to 0, p of x is false statement because p of 5 is not true. No, if I take p of x is 5, so it will be what, if you take 5, it will be 5 plus 5 is less than 9, so 10 is less than 9, which is not possible, therefore it is a false statement. Okay. Then you have existential quantification. For existential quantification you can take this one. Here you can take when we are using together existential quantification and yes, see, we'll take this example. Here you have p of x denoted as a symbol x is equals to x plus 1. What is true value of quantification for there exists q of x, where the domain consists of all real number. So if the domain is real number, then q of x will be false. Now q of x will be false. For every real number x, the existential quantification of q of x, which is for there exists x p of x will be false. For real number, this doesn't satisfy the value. Okay. Then you have next one. If you are using together nested, that is universal and nested quantification, they can write it in this way also. See, for they exist, you can write X is rose and Q X is red. We can write there exists X if X is rose and it is red. That is symbolically written in this way. Other one, if X is a dog, then X is an animal. We can write X is a dog and X is an animal. The above statement can be written as for all X. If X for all X, uh, X is dog implies if and only X. If X is a dog, then X is an animal. Okay. Then you have nested quantification. What is mean by nested quantification? So quantification, what is nested quantification? It is two quantifications are said to be nested if one is within the other. If it is one is within the other, then it is called as nested quantification. For example, you have here for x there exists y, x plus y is equals to 5. So for here they have given you have for all x there exists y. Okay, then x plus y is equals to 5. You substitute the values and check out what answers we will get for this. So it is for x plus y is 5. I can write this as y is equals to 5 minus x. Now write x is equals to 0. So if I take x is equals to 0, what we get? Y will be 5 minus 0, it is 5. Then if you take x is equals to 1, y will be 5 plus 1, 5 minus 1, it will be 4. So if I take x is equals to 10, so y will be 5 minus 10, it will be y will be minus 5. This means what? If you have x value, then only will get y value. If you have x, for every x we will be having there exists a value y. Okay, that is nothing but called as nested quantification. Then yeah, then next topic we have is rules of inference. What is mean by rule of inference? The rules of inference, also known as inference rule, are the logical form of templates consisting of premises or hypothesis or drawn a conclusion. So whenever a statement is having premises and conclusion, it is called as rules of inference. So now we will discuss some of the rules of inference. Before we could go for rules of inference, we have valid argument and a structure of argument. What is argument? You have some like n number of conditions, and for that conditions we have the one solution called a q. That is, an argument can be defined as a sequence of statements. We have many statements, then and only one conclusion. For example, we can take, you have student p1 will be the student. So you can take your example as, suppose we have a premises 1 are the student who score 100 marks. Then premises 2, student 2, student who score 70. Then P3, student student who score 60, and P4, student scoring 50. So if the argument is we want a student who is scoring more than 70, so 70 and above means we will be taking the conclusion will be, so if I want the conclusion that the student who score more than 70 or equal to 70, student scores equal to 70 or equal to 70. So how many are? We have only one student. So the conclusion Q will be student scoring 70 will be only 1. So here we have n number of premises, but the conclusion will be only 1. So yeah, now we have some next is called a valid argument. What is mean by valid argument? If all the four premises are true, then the conclusion is also true. So yeah, if the premises, all the premises are true and the conclusion is true, then it should be a tautology. Then if the condition is a tautology, then it is called as valid argument. For example, we'll take this example. If you have a current password, then you can log into the network. If you have current password, it will be P, and Q, you can log in onto the network. So here P will be you have a current password, and Q will be you can log onto the network. So now what will be the argument? Argument will be P implies Q. We can write P implies Q, and P will give you negation and will give you Q. That is P and Q. Okay, and P, when you take, we will get the answer as Q. So this statement should be a tautology. Then we can say that the given argument is a valid argument. So we'll just check it whether it is a tautology. So yeah, we have P, Q, PQ. Then we have P implies Q. Then we have P implies Q and P. I'll call this as 1. Then it is 1 implies Q. So if I take here T T T T F F T F T F T F T F, then P implies Q is T and F, it is F, otherwise it is true. Then P implies Q and P means we have to check the condition for first one and third one. Condition is and means T and T, it is T, otherwise it is false. Now we will be checking for 1 implies Q, means we have to check in reverse order. Okay, so implication for like property is F, law is T F, it is F. We should check in the reverse way. T T, no we don't have. F T we don't have. F we don't have. F and F we don't have. We don't have this condition, so the remaining all will be T. So the given argument is a tautology because all the values are true. It is a tautology, therefore it is a valid argument. Valid argument. So we have many laws of inference. Many laws of inference we have. We'll just argument. Valid argument. Okay, so we have many laws of inference, we'll just discuss. And in this law you will be getting one law 100% in your question paper, so try to understand the laws. So here first law is called as modus ponens law or law of detachment. What is modus ponens law? Modus ponens law is the same example what I've explained you, it is the same thing. Here it is P implies Q and P gives you Q, which is if we have a bank account, then we can use Google Pay. P, we have a bank account. Q, we can use Google Pay. Only if we have a bank account, we can use the Google Pay. So that will be modus ponens law. That will be here P implies Q and P. It is P implies Q and P will give you Q. This is the same example what I have explained you here. Okay, this is an example even for modus ponens law. Modus ponens law. Okay, then moving on with the second law, it is second one is modus tollens law. What is mean by modus tollens law? Modus tollens law, it says suppose we have the two premises P and Q. We have two premises P and Q. P implies Q will give you negation Q, that will be even negation P. So this can be written as P implies Q. This will be and always, and negation Q will give you implication of negation P. So this is how we'll write the statement which will be given in the form of law. Okay. So yeah, negation Q. This is called as the modus stolen law. For example, if we have a bank account, then we can use Google Pay. If we cannot use Google Pay, we do not have a bank account. So this statement is we cannot use Google Pay if we do not have a bank account. Okay. Then next one you have is hypothetical syllogism. Hypothetical syllogism. What is hypothetical syllogism? Hypothetical syllogism says it's like a transitive property. It says if it is P implies Q, then Q implies R. Q implies R will give us P implies R. The one which is common, we are not going to take that. The common one, we will leave it and we'll take P implies Q. Okay, therefore it is P implies R. Now, it can be written as P implies Q and Q implies R. Q implies R will give you P implies R. So this is called as hypothetical syllogism or a transitivity of the given problem. If my fiance comes to meet me, I will not go to office. Q implies R. If I do not go to office, I wouldn't work for a day. Then P implies R only. If my fiance comes to meet me, I do not work for a day. So this is what is called as hypothetical syllogism. Next one you have disjun- uh, dis, uh, disjunctive syllogism. Disjunction syllogism. What is disjunction? Here it says disjunction syllogism says you that it says here P R Q implies P will give you Q, will give us Q. That will be P or Q and negation P will give you, will implies Q. So here we can see that P and negation P are reverse of each other. So what will be left out? Left out will be Q. That will be called as disjunctive syllogism. Then for example, negation P birthday cake is not strawberry flavored. P and Q, the birthday cake is either mango flavored or pineapple flavored. Then Q, the birthday cake is pineapple flavored. Then you have next one is called addition. Addition. What is mean by addition here? Addition says yeah, addition law says if you have P, then we'll have P or Q. For example, you have Rajesh is a hard working employee. Rajesh is a bad employee. We can say neither Rajesh is a hard working employee nor Rajesh is a bad employee. Then we have next one is called simplification law. What is simplification law? Simplification law says P and Q, we will get a P itself. P and Q will give you P itself. For example, Indumati is a hardworking employee and she is the best employee in the office. So, Indumati is a hardworking employee. If she is the best employee in the office, she'll be hardworking employee. Okay. Then you have conjunction law. In conjunction law, if we have P and Q, then we'll give you P and Q together. Then you have resolution law. It says resolution law says P and Q, P negation P or Q will give you Q or P. So how it is? So here we have already discussed P or Q, negation P or R. Again, this both are opposite of each other. We can neglect that and write P or R. So this property is called simplification. That is resolution law. Okay. Then we have next one is, these are the important laws which we'll be using when we solve the problem. For example, they have given here one problem. We'll just try to simplify this problem. Okay. Now, see here, one problem is given. The question is, let us assume that the variables are two premises. P, it is a sunny, it is sunny this afternoon. Q, it is colder than yesterday. We will go to swimming. We will take a Mysore trip. We will be home by sunset. So yeah, we have a, we can take they can be given argument can be converted in the form of we can prove this by using the laws. Okay, I'll take this example. It will be easy for you to understand. So yeah, and it was asked in one of the papers, so let me complete explain you this. Test the validity of the following argument. If milk is black, then every crow is white. If every crow is white, then it has four legs. If every crow has four legs, then every buffalo is white and brisk. The milk is black, so every buffalo is white. So let us consider this in the form of premises. P, the milk is black. Q, every crow is white. R, every crow has four legs. S, every buffalo is white. And T, every buffalo is brisk. The argument is valid. Valid means we have to get the validity, that is all, it should be a tautology or it should be true. Okay, we have to prove it. So now first condition is what? If milk is black, then crow is white. That is P implies Q. Then if crow is white, then the hat four legs, Q implies R. Then if every crow has four legs, then every buffalo is brisk and white and brisk. R implies S and T. Then the milk is black, it is P. And the conclusion, so every buffalo is white is your S. Conclusion is S. Okay. So we'll just prove by using the arguments here. So it is, yeah, it is given. P implies Q. It is this is premises 1. Then second premises is Q implies R. That is your second premises. Okay. Then by using hypothetical law, what is Q, since Q is repeating, we will ignore that and write P implies R. That is hypothetical syllogism of 1 and 2. Then we have next statement is R implication of S and T. Then again we can see in second and third R is repeating, so we can write P implies S and T, that is syllogism, hypothetical syllogism for third and fourth. Then we will take next one as P. What is the next? That is premises 4. Then we have P implies R. Therefore, we have written already, that was P and P implies Q, and and P will give you what? It will give you Q. Okay, but which one? It is Modus Portland law. We had the Modus Portland law. It says P implies Q and P will give you Q. That is Modus Portland law for 5 and 6. Then we have other one, S and T. S and T will give you S. Which one it was? It was a simplification law. So by using this, we prove that the given argument is valid, where S is the conclusion. Okay. Now these are the inference laws and problems on that. Then you have rules of inference with the quantification. So first one is called universal instantiation. Instantiation, that is for all x p of x will give you p of k. That is, suppose for example all women are brave, therefore Sita is brave. We can say example, if all women are brave, then the Sita is also brave, because Sita is a women, she is also brave. The second one is universal generalization, that is if p of k is true, then for all x p of x will be true. That is Sita is brave, therefore all women are brave. Then you have existential instantiation, that will be there exists x p of x gives you p of k, means there is someone who runs in a kilometer in 5 minutes. Let's call him Rama, and say Rama runs 5 kilometer in runs a kilometer in 5 minutes. Okay, then existential generalization is p of k. If there is p of k, then there exists x p of x. Rama runs a 5 kilometer in 5. Rama runs a kilometer in 5 minutes. Therefore, someone can run a kilometer in 5 minutes. Will be the answer. So here we have some of the examples again they have given. Just go through with this all examples what they have given. Then you have universal modupolar law, that is for all x p of x implies q of x will give you p of a by q of a, where a is a particular element of domain. This rule is called as universal modus ponens rule. Okay, then you have universal modus tollens rule, that is for all x p of x implies q of x, imply negation of p of a, q of a will give you negation of p of a. Okay, these are the some of the rules. The last part of this topic is you have theorems. What is theorem? Proving any statements, right? We have different types of many theorems we have. What are the theorems? It is a statement which we are going to prove, no? So here we are going to learn about methods of proving theorems. We have some methods of proving theorems. We'll discuss the few methods. Okay, first method is called direct method. Proving methods, we have direct method. What is this direct method? Indirect method, for example, it is p implies q. Okay, then q is true. We have to prove if x is a even integer, x square is an even integer. The statement is if x is an even integer, then x square is an even integer. So we'll take p is x is an even integer, q x square is an even integer. Okay, x square is a even integer, p is a even integer. Then we can prove that since it is an even integer, we can take by hypothetical law that x is equals to 2m. Why it is 2m? Because it is a multiple of 2, okay, or even number, where m is an even number integer. Okay, now we have to prove the square. So squaring both the sides, we get squaring both the sides we get squaring so you have squaring both the sides, we get x square is equals to 2m whole square. That will be x square will be 4m square. So yeah, 4 is can be written as 2 into 2m. So it is again a multiple of 2, no? Where x square is equals to 4m is nothing but 4m square. It is a multiple of 2, therefore x square is even. X square is even integer. Where p implies q is true. P implies q is true. Is called as direct method. Okay. Then you have next one. Second method is called second method is called proof by contradiction. Proof by contradiction, contrapositive and then contradiction. What is contrapositive? We need to prove it as p implies q. What is contrapositive means? P p implies q. We need to prove it as equivalent to negation q implies negation p. See, for example, if you take prove that n is integer and 3n plus 2 is odd, then n is odd. So we'll take letter 3n plus 2 is odd integer, then 3n plus 2 is 2k will be even, plus 1 if you add it will become odd. So 2n plus 2 is equals to 2k plus 1, that will be This 3n plus 2 minus 1 is equals to 2k. So it will become 3n plus 1 is equals to 2k. This does not seem to be any direct way to conclude that a n is odd. So what we can do, let us assume that method of contrapositive. Contrapositive. What is the contrapositive? We'll take reverse. N is not odd, then 3n plus 2 is not odd. We are taking a reverse. If we are taking negation q and negation p, then n is even, n is equals to 2k. If it is not odd, it should be even. So n is even, n is equals to 2k for some integer k. On substituting 2k for n is equals to 3n plus 2. If you substitute here in place of n, we get 3n plus 2, where n what we are taking it as 2k is equals to plus 2. So it will be what? 6k plus 2. What is common here? 2 we can take. That will be 3k plus 1. If it is a multiple of 2, it is what? It is an even number. This in contrapositive statement, if n is even, then 3n plus 2 is also even, is true. Therefore, n is odd. Okay, therefore n is odd. It will be called as contrapositive proof. Then the last one we have is contradiction. I think this you might have done contradiction, which we had done in 10th standard. So what is that? For example, we have show that root 2 is not a rational number. So what we do usually to prove this, we will take a contradiction method. What is contradiction? We'll take reverse of this. Root 2 is rational, then root 2 will be equals p by q, where p by q should not be equal to 0, and q and p and q has no common factor. Now, by using this squaring both the sides, we get root and square will get cancelled. If you square this, root and square will get cancelled. You get 2 is equals to p square divided by q square. Then, sending this q other side, it will become p square. We have root 2 is irrational. We'll take it as root 2 is p by root 2 is p by q. Squaring both the sides. If you square, we get squaring both the side, we get. So square and root will get cancelled. That will be 2. Q square will come this side is equals to p square. So we can write that p square is even. If p square is even, p is also even. Now since p square is even, p is even, we'll take p is equals to 2m. Substitute in the formula. Here in this formula, p square is 2q square. 2m square is equals to 2q square. 2 square is 4, m square is equals to 2q square. Then cancelling, 2 2s are 4, 2 1s are 2. We get q square is equals to 2m square. Means what? Q square is even, means q is also even. Hence p and q has a common factor 2, which is a contradiction to our statement. Therefore our assumption is a contradiction. Therefore root 2 is irrational. Then we have the proof by counter example. Proof by counter example. They have given here 3 is equals to a square. For example, show that the statement every positive integer is the sum of square of two integers is false. So if you take 3 is equals to a square plus b square, where a and b are two integer. Now squaring this, values are lesser than 3. Only value that can take is 0 and 1. No, 0 1 square. 0 square plus 1 square will be will be equal to which will be false. If you take any value like 2 and 1, if you take you get a 2 square plus 1 square is 4 plus 1 5. So 5 will not be equal to 3. So any value we take, the value will be false itself. Okay, he's asking you to prove it is false. Then you have prove method and strategies. What is prove method by strategies? First method is called exhaustive proof. Exhaustive. What is mean by exhaustive proof? Some theorems can be proved by examining a relatively small number of examples. Such a proof are called as exhaustive proof. For example, if you take this, the given value, you take n plus 1 whole cube is greater than or equal to 3n if n is a positive integer where n value is less than or equal to 4. So what we get here? So you can take this one. We have n n plus 1. One second. So if you take n plus 1, n plus 1 whole cube is greater than or equal to 3n, where n value is equal to 4 or greater than lesser than 4 means n will be 1, 2, 3 and 4. So substitute the value. If n is equals to 1, what we get? That will be 1 plus 1 cube will be greater than or equal to 3 into 1. That will be 1 plus 1 2, 2 cube will be greater than or equal to 3. 2 cube is how much? 8 greater than or equal to 3. So 8 is greater than 3, it is true. So it is true. Same way you will be proving for n is 2, n is 3, n is 4. We get this values. N is 2, n is 3, n is 4. We get the values where in each of the case the inequality holds true, hence the given equation holds true. Okay. Then we have the last one called proof by cases. What is proof by cases? They'll give you sometimes we cannot prove the theorem using a single argument that holds for all possible cases. We need to consider different case separately. So we can have, like for example, if I take example here, prove that n is an integer where n then n square is greater than or equal to n. In this case, integer, what are the values we get for integer? We have positive, negative, positive and 0 and positive values. We have negative values, positive value and 0 in integer. So we have three different cases. So you should prove for three different cases. If n is 0, 0 is greater than or equal to 0, which is a true. Then if it is n is greater than 1, so if you take n as 1, so it will be 1 square will be greater than or equal to 1. That will be 1 will be greater than or equal to 1. That will be 1 will be equal to 1. It is true. Then you take negative 1 square is greater than or equal to 1. That will be 1 plus 1 is greater than or equal to 1. 1 is greater than 1. Again, it is also true. So the given all cases are true. Therefore, the given argument is also true. Okay. So these are the different methods which we have learned. Just go through with the helpful unit I have just completed. In the next class, we'll start with the basic structure, where we will be learning about the here in the next unit, next video, I'll be explaining about set, function, sequence, and